welcome back to the lecture series in bioenergy. So, in the last class we talked about the gasification. If you look at the advantages of this gasification process, so advantage of gasification, let us talk about the advantages. So, advantages is basically the gas produced can be standardized and in its quality and is easier and more versatile to use than the original biomass. And as a matter of fact, this gas could be used for gas engines, it could be used for gas turbines, it could be used for chemical feedstock for producing liquid fuel, okay. Chemical feedstock to produce liquid fuel. And here I wish to, since now we have talked about the whole process. So, we have talked about, we introduced the concept of gasification and then from there we moved on to the basic chemistry. So, we talked about the basic chemistry where we showed in the stage 1 you have partial oxidation of carbon, you have complete oxidation of carbon followed by the production of methane in the second phase. So, here one interesting thing what I wish to highlight, you might be wondering that this is what is happening in a very, the kind of conditions what we create is kind of a very high temperature, high pressure, whereas nature produces it through geological era, can create that because it is far below the earth's surface where you have high temperature and you can do that. So, whenever we talk about any process which requires high temperature, high pressure, we are talking about increasing our input cost to produce a fuel. So, whenever we have to talk about economics, whether this will be a feasible technology or not, one has to keep in mind that this is the input cost what is being put in order to produce this kind of materials. But if the input cost is good enough that we can compensate for it, sure, there is no issues. But there is another route. This gasification is not purely happens by thermochemical processes, though we will not talk about it today. But just to give you an idea about when we talk about gasification, if we go back out here, there are two routes by which one can think of gasification. One route of gasification is the one what we are just now discussing, which is basically a thermochemical process, okay. Thermochemical process, where you are giving high temperature and high pressure and you are developing it and you are using air, we have already talked about it, you are using oxygen, you are using steam and at a temperature more than 800 degrees centigrade. Whereas, the other route is the biochemical process, which is a very, very lucrative route, biochemical process. This route essentially use microbes or mostly anaerobic microbes Anaerobic means the microbes which grows in the absence of oxygen, anaerobic microbes, and could carry out the reaction at an ambient temperature, which is around 35 or 37 degrees centigrade. Okay. So, if you think of it, so it's basically the process is called anaerobic digestion. So, we haven't yet touched upon this point, we will be coming later. So, what I wanted to highlight here is something which always struck me, that whenever we talk about the sources of natural gas, I personally believe that it was not exclusively a thermochemical conversion which has taken place in nature. Probably thermochemical conversions have been supplemented with microbial digestion processes, because otherwise the process efficiency will be not that high. So, another approach of studying gasification are with the microbiologists who are working towards energy, where they look for different kind of microbes which could produce methane from biomass, okay, or they could produce other different kind of combustible compounds from biomass. So, we will talk later about that. So, at this point what we will be delving into is we will be talking about the thermochemical conversion. Okay. Now, from here what we will do, we will move on to the part 2 of it, what are the 3 product qualities which can be produced by gasification. So, there are different kind of different range. So, what are the different kind of product gas what we are getting? Okay. There are 3 different kind of product gas what we obtain from this whole process. 3, and here we will be making a comparison with the natural gas which is produced in the nature, and how close we are to that and how far away we are from that, and that will help you to kind of figure out what kind of technology we needed to really use in order to get good quality gas. And there is one more thing which I kind of skipped through, to realize that the reason for there is so much thrust on gasification process is this, because it is a lighter fuel. Whenever we talk about liquid fuel or solid fuels, they are heavy, right? Gaseous fuels are lighter, they are easy to carry, they are easy to transport from one place to another. So, if we get the right set of conditions to produce whole tons and gallons of such gases, then it could be easily transported from the existing gas lines which are already laid all over the world. So, it is a very interesting journey of mankind, where this is aspect which I wished for you people to philosophize very clearly. We are now engineering nature by learning from nature, because this is the first time possibly in the history of mankind this is happening. We are exactly following the protocols or the blueprint what nature might have followed through geological eras and through ages to produce all these natural resources for us, which are very good quality fuels. Okay. So, now coming to the 3 different kind of product gases which are produced, 3 different, which basically quality control wise, product gas qualities can be provided by varying. So, I told you there are different conditions which you can vary during gasification by varying the 3 parameters you can vary: the gasifying agent 1, B, method of operation, C, conditions or operating conditions. Okay. Operating conditions. Now, if we talk about the gasifying agent, there are three different kind of gasifying agent we have talked about. We have talked about air, we have talked about oxygen, we have talked about steam, and we have also talked about hydrogenation, where you are giving hydrogen. In other words, you are reducing the product. Okay. And sometime further you can do catalytic steam gasification is also further followed. Okay. You are using different kind of catalytic routes or catalyst. Okay. Catalytic steam gasification. Okay. So, these are the different gasifying agent which are being followed, and what you get out of this is you have three class of stuff with different calorific value which you obtain. One is low calorific value, CV stand for low calorific value. You get medium calorific value and you get high calorific value product, high calorific value products. And in terms of the numbers vary from Newton meter cube 4 to 6, okay, 4 to 6. Okay. Now, mark at this number. So, you have medium one which is you get 12 to 18 megajoule per Newton meter cube, whereas for a high calorific value you get megajoule per Newton meter cube. And in terms of the utility, so before we get to the utility, what are the different kind of gasifying agent which are used? So, here you are using air, steam slash air. Okay. Here you are using oxygen and steam. Here you are using oxygen, steam and hydrogen or hydrogenation, what you are doing. So, these are the low calorific value is directly used as an engine fuel, whereas these two are used, these are the feedstock for subsequent conversion into basic chemicals, principally methane, into methane and methanol and all those kinds of product. Okay. So, now the question arises that why there is such a low calorific value obtained when we are using air or steam slash air. Now, if you look at it again carefully, so look at the value, compare the value 4 to 6, 12 to 18 and 40. This is a significant difference. Even if I take the higher value, say 6, 18, 40, that is 3 times and this is another 3 times, almost 3 times, okay, 18, oh, okay, twice, okay, 18 to the 36, okay, at least twice. Why there is such a huge difference? Now, here is a catch, and that is something worth tinkering about. When we use air, air has a high percentage of nitrogen present in it, and nitrogen actually dilutes this reaction big time. And since, so what you see out here, if you look at it carefully, this air what you are having, it has nitrogen, and this nitrogen is a problem. Whereas, if you use pure oxygen, which is being used here, this is expensive. You have to have a pure oxygen to do this reaction. This is not something very easy to do. Okay? And here you have another added feature, you are using hydrogen, which has also become expensive as well as risky affair when you are dealing with hydrogen. You have to be very careful while dealing with hydrogen. You have every chance of blast or something, you know. Now, it is a kind of a trade off. Now, in the hindsight or retrospectively, if you think when nature has developed these kind of gasifying products, or like the product gases under the earth, there are hardly any air there. It was lack of oxygen. It was or kind of partial combustion. So, the route possibly it has followed is a very tricky route, and there are a lot of microbes there which has led to the production of lot of carbon dioxide by a cheaper route. So, if you are a thermochemical guy and if you have another collaborator who is a microbial guy, the challenge will be both of you sit on the table and really optimize this process where you can introduce microbes to bring down the energy of it. And think of it, this brings us to another aspect of it. When we talk about this hydrogen production is a big story. If you remember, while we talk about photosynthesis, I told you there is lot of work happening across the world where they want to produce hydrogen, because hydrogen itself could be used as a fuel, hydrogen itself could be used as a reducing agent. There are so many things where hydrogen could be very helpful. Okay. So, what I wish to highlight here is that we have to think very holistically. And now, this is the really eye catcher if you look at it. If we talk about, if we compare these three values with natural gas, here is the number. For the natural gas, I am just keeping for you people all the three values, and if you see the natural gas, the calorific value of CV stands for calorific value of the natural gas, that is 36 megajoule per Newton meter cube. Now, you just compare. So, here is the natural gas which is 36, you have 6 low calorific value, I am just taking the higher values. Okay. You have 18 which is medium calorific value, you have the highest calorific value 40 after a lot of expenses in terms of you have to have oxygen, hydrogen and likewise, and here what nature has produced. So, challenge is to consistently get something in between a medium and a high calorific value feed, and this is not something, and if you look at the efficiency of conversion of both, so what we did previously, the pyrolysis and gasification. So, gasification slash pyrolysis, for both the technique, the biomass conversion efficiency is around 75 to 80%. So, here is a catch. If natural gas is 36 megajoule per Newton meter cube, whereas the calorific value, whereas with our highest expenses we are getting 40, which is marginally different, and our low calorific value is at least 1/6 of what we get from natural gas, which is 6th if you again visit this, because this is what is the take home message. Here you have the 6, here you have 36, which is 6 times. So, how we can reduce that from 6 to 36? What will be the route? How you will do it? I am supremely confident that this cannot be achieved by one particular route. It has to be done in conjunction with a microbial route, which will be coming later into it. Okay. That there has to be a microbial approach into the game, which will help us to realize our dream of moving from a 6, the value of the calorific value, to 36, which is standard natural gas wherever you obtain. Now, where all you can really put your fingers into the process. So, one of the processes where you can think of is what will be. So, if you go back, what all we have covered now as of now. So, we have talked about the two routes, thermochemical and the biochemical process, but we have not talked about the biochemical yet. This is what we will be dealing later, but we have started with the thermochemical. So, we talked about the introduction, this is we are done. We have talked about the basic chemistry, we have done. So, we have talked about the basic chemistry and we have talked about all the different efficiency parameters, and what I am proposing for you guys to think differently. You have to integrate these two. As we will talk about the biochemical process later, you will realize why I am telling you to. We have to think very differently, very judiciously. Now, what we are talking about is where we can intervene, where we can make the process go more efficient. So, one of the approach where one can make the process or increase the efficiency of the process is by selecting the right kind of biomass or right kind of feedstock. So, what kind of feedstock we will be using for this purpose? It is very, very essential, because this will take you back to the original ideas what we have talked about, what kind of, and we will discuss in depth about it. And then could we do some kind of a pre-treatment before we introduce these materials in the gasifier, because we can allow the reaction to take place much more faster, or could we use different kind of catalyst which will increase the reaction faster? Could we introduce some kind of microbial treatment which will make this kind of feedstock much more amenable to modification to form methane or those kind of things faster? So, what we will do next is we will talk about the feedstock treatment processes and the properties of the feedstock. And the third aspect which is out here, which is the gasification type, it is more of an engineering aspect of it, what kind of gasifier we will be using for what kind of material, because different material needed different form of or different kind of treatments, different pressure, different oxygen tension, different temperature, different level of steam. So, what will be the material, what will be the process, and what will be the safety measures for using different kind of gasifiers. Because if we think that one day we will have this as kind of part and parcel, just the way you see most of the petrol pumps, you will have gas filling stations, just like you have the natural gas filling station all across India. Similarly, so what you have to do, you cannot, so you will have to have local hubs. This is the aspect we will be dealing later. Local hubs. So, this region you have a local refinery, the next village has another refinery, third village another. So, you have different locations where you will have eco-friendly hubs, where you will be converting the biomass or the feedstock into different form of energy, like gaseous form, liquid form, solid forms, and like so on and so forth. So, it will be a long journey which will bring us, it will be kind of a consortium of microbiologists, engineers, bioengineers, chemists, chemical engineers, reactor designers, economists, and socio-politicians who understands what people like to use, because it is not that every time you introduce a technology it will be accepted by everybody. It has to go through the whole regurgitation process of people liking or introducing it in the right way. So, what I will do, I will close in here today, and we will start with the feedstock treatment in the next class, and we will talk about the biomass properties, and followed by we will talk about the gasification types. So, this is what will be in store for winding up the gasification process, and after that we will move on to the anaerobic digestion process, which is another route of gasification, and what are the seminal discoveries in that area, what are the modern technologies which are being used on it. Okay. So, with this I again wish to reiterate the fact, please go through these notes, because I do not have any other separate notes as such, because this is what I am putting exclusively. So, you do not have to refer to anything, and try to understand the basics. Do not get bogged down, because once you get the basics right, then you can refer to any book and it will be clear to you, instead of really getting bogged down by the books all over the place. Okay. Thank you.